are using mainly product from satellite data. So it is not a satellite data itself, because here you can range it in level. It is level 3 or level 4, because there are two products here we have. One of them is from NextGEO and the other one from CMEMS. So both of them based on satellite, but they are not satellite data itself. So let us go for the presentation now. And as Benta said, I will try to make a kind of very brief about QGIS. Maybe a lot of people using it or they use part of it, but here I will just introduce QGIS. And we can say, why QGIS? QGIS is a free software, so you don't need to pay anything for it. It works for cross-platform applications, means that it works for Windows, it works for Mac, it works for Unix. So all these program, or all these software, or all these operating system, they can use QGIS. The other thing, what is it? It is a geographical information. So it's based on geographical information. It means the data is to have a geographical location, or the same like other geographical information system, it's based on coordinates. Good thing about QGIS also, it imports different data format. Number 3, it exports different data format. Also, it works with raster data, gridded data, or with vector data, which is points, lines, and polygons. I put also here where you can get it. You can get it directly from the home page, that's downloadqgis.org. One of the things that we mentioned also, it is open source. It means you can contribute it. So there is no, everybody can contribute, and that is the reason when they release it, the version here released according to the date of the release. So for this tutorial, we are using 3.8. When you starting this, there is two ways you can start QGIS. If you are a beginner, example, somebody give you a complete project that include everything, so you just click directly on the link he sent it to you, or on the file he gave it to you, and usually it is ending, or the extension of the file is QGIS. This is one way. The other way, you click on the icon of the QGIS in your desktop, and then you start to load your data file by file. The nice thing about when you get a project ready, then all the data is there, or the data here, where I mean, it is the layers. And the other thing that also, one of the main thing, how do you define the coordinate system you are using? I will come that in details when we are presenting our data here. So here we have, when we click, like now we got the link, you can see it on the screen here. That is, if you just double click, you will get something like that. It is the map showing Svalbard in the middle, Greenland in the left, according to what I see in the computer. And you have on the top here, you have Franz Josef Land. What the map mean? That is the sea ice concentration map. The dark blue, that is water, and the rest is ice with different kind of concentrations. Two things you can do. If you go to project and you see the properties of the project, you will get a window which will describe many things, or you can find a lot of information. Example, in general, you can find the project file, where it's located in your disk, and also use the project name, metadata about the project, and the most important thing, also you can find the coordinate system of the project. Okay, now we have a project with all this information, and if you look at the lower part here, you will see the layer that we saw, which is the ice concentration. If you also click on the right click and then look at the properties of the layers, you will find a lot of information about the layer itself. Example, it's presenting ice concentration, that's the coordinate system, and then you have the extent of the data, how many bands, what kind of units, how many pixels, like width and height. This is one part. If we go to the homology, you will get how do you here you color your data, because I mean, like any kind of product, they have to have a kind of a special color range. So according to that, here you can play with that. Also on the top here in the render, how do you present this data, or how you want to present this layer? Is it multi-layer, like more than one band, so you can present it in like RGB, or also it is one band layer? Also here, you define like the color you want to use, and also here you can like visualize and play with the histograms and the transparency if you want to remove the transparency from the layer. I think that is it for the just small introduction about the QGIS for the people whom they don't have background about it. Now we come to the main thing here. We are comparing sea ice data from NextGEOSS and CMEMS. CMEMS, that is the Copernicus Environmental Marine Services. They have a catalog, and NextGEOSS have a catalog. Our presentation, or how we will go through it, we will first search data, download it, then visualize it in QGIS, make very simple analysis for the people who are really experienced, comparing the two data sets, and then making maps from that. So for the NextGEOSS, here we use the thread, which is already offered by Nansen Center. And on the red box, you see the 3 images for the people who are familiar with Sentinel. That's Sentinel-1B. Sentinel-1 is used, it is the SAR, the synthetic aperture radar. So it uses the microwave from the, the C-band. The data here is product based on these images for producing a classified images for sea ice and water. The algorithm we developed here at Nansen Center, it can run automatically for huge amount of data for whole Sentinel-1A and Sentinel-1B. So let us now download these 3 files. All of them are from the 23rd of July, 2018. And you can see the extension is NetCDF files, and that is very common now for distributing a lot of data because it is very handy for a lot of people. The other data is from Copernicus, from the Copernicus Marine Services, and that is the homepage you get to when you just copy and paste the links that I have it on the top of the slides. For downloading data from this site, you have to register. But browsing the data, there is no problem to do that. As you see, we have 3 boxes. We have ocean monitoring indicators, and we have state report. If we click, because we are interested in ocean data now, if we click on the green one here, then we will get to the page. You can see the number of products here is more than 174 ocean products. On the left part, you have here, you can define the parameters or define the region you want to download the data from, and also what kind of data you want to download. We go further. Now we define the region, the Arctic Ocean here, and then what we need parameters, we need sea ice. And then we have the product that we are looking for. In the lower part, you can get more information about the product, or you can add it to the chart. It is free of charge. I mean, you don't need to pay anything for downloading this data. Just it is a part of the system that they know who downloading it and how many downloading it and what they are using for. That's the interesting part for the organizer for this. After downloading the data, now we need to visualize it in QGIS. As I mentioned at the beginning, usually if you got a project ready, you just click on it, you will get directly to the layers, all the layers. But here we start from scratch. We just double click in the icons of the QGIS. We open QGIS now in front of us. The first thing you need to define the coordinate system you want to use. And since we are downloading data from the polar regions, we have to not to depend on the system that is or coming, because it can be any kind of, you will project the data on the right place of it. So here we choose North Pole historiographical, and there is many project systems available in QGIS. You can define according to what and where you work. So we usually go to properties, and then in the project properties, we define the coordinate system. Then now we are done. We have done that. Now we go back again and then try to open the file. When you are opening an SCD file, it is really important to know what layer you want. Because, example, if you look at when I downloaded data from CMEMS, there you can define the date of the data from that time of the period of the data from special day to I mean like how many days you want from the data. Depending on the size of the file, you can download it directly or you can download it in part because they have a limitation on how big the file can be. In this case, I mean like you can download several days of ice chart. What I mean here, this layer is the ice chart or ice concentration chart. So you can download different layer. When you are opening the GIS, you need to know which layer you want to open. So this is how it looks when you first visualize the data or the NextGEOSS file that we just downloaded from the CMEMS. Now we need to go to the properties of the data, the properties of the file that as I show at the beginning here. I will right click and then go to the properties. I will get the window that I can define the color, how they should look. I can rotate the image, do what I would like there. And the most important also on the top of when I say the rendering or which band you want to see, because here you will get all the days. The software will pick the top one, but generally you need to know what date you want. So here we are using the data from the 23rd of July. That is the same images that we downloaded or the same product that we downloaded from NextGEOSS. Now we have 3 files that I said downloaded. That is the same here. We put all the files. You can see all of them. There are 3 files, which is 3 tiles of images. They are laying now on this from the north to the south, and that's according to the motion of the satellite. It takes it, and each one is 500 kilometers west, and it will go down like that. So that is from the same day. The difference can be seconds between these images. I cannot do the same thing that I have done it with the ice chart, the one that is downloaded from CMEMS, because here we have 3 layers. It is possible to go one by one. Instead of going one by one, I would like to make them all as one image. Instead of taking one by one image and take the properties of each image and fix it, because maybe I will not be right. So according to this, we will merge. That is a very simple processing. We will merge these 3 images to get one file. How we can do that? There are steps, clear steps. First of all, I will save all the images because as I mentioned, they are NextGEOSS files. I will save them as duty files and then export them and save them as new files. After that, on the top of the program or the software, I will go to new processing toolbox. I will search and locate the GDAL raster, and then I will go merge tool. Then I will get a double click on that, and then I will get a window where I can define all the specific parameters that I would like to define. The type of data, where the file should be saved, and what kind of format. Here we have done that in TIFF. And now you can see we get only one file. I didn't mention the color because I think Rafael asked before. You can see that the color here, 0, that is water, 0 concentration, and then I have 25, and then I have 50, and I have 75 and 100% ice. That is the top of Greenland, and that's very common according to the sea ice for this area. And now we have these images, all of them in one file. So we have 2 colors only. We have ice, which is white, and that is also in nature like that. And the dark is water in the image. The black color is water in the image. Then now, for comparing these 2 data sets, one of them can be visualized, like I can look at it, like visually compare them, or the other way that is by using the contrast of the images, or the other way that I create a Shapefile. I think people know Shapefile is really famous vector layer for people using geographic information system. And in definition, Shapefile can be points, can be polygons, can be line. So what I will do here, I will draw a line on the top of images and compare the line with the chart underneath. So let us go to the to the image contrast between. Now we just removed the, we just give the water the same color as the water available, or the same color that presents the water in the ice chart. Then now we will try to play in the contrast or reduce the transparency on the top layer. We have done it like the same. We took like 100, this is 100 now, and then we make 50, 75, 50, and 25. So how here we look like the product from this, like when I increase the transparency of the top layer, and how the two layers are matching. Is that interesting for us? I can talk about that later, why we want to match them, because these two products are produced in totally different way. One of them is produced from a lot of satellite and human intervention is a lot of it. The other one is completely automatic. The script written in Python for classification. You just put the image and you will get it classified to water and ice. Now we go to the next step, that is to create a shapefile and then draw the line. There are several ways you can create a shapefile in QGIS. You just go to the menu layer and then create layer, new, and shapefile. Or you just click directly here where you can create a new shapefile. Then a dialog box will appear. Also, you need to define the specific or specification of the shapefile you want to create. Example, first of all, here we will not pick, because you have 3 categories you can pick from. You can pick point, you can pick line, you can pick polygons. We will pick a line, and then the specification of the line, or the how it looks, color, thickness, and all these. What we do after that, then we will start to toggle or to start to edit by clicking on the kind of a pen on it, and then we will zoom in and out and try to trace exactly where the ice edge from the images that is downloaded from the NextGEOSS catalog. And we will continue with that, and we will reach this. This is how they look, the line we draw from the beginning. So now we have on the layer window, we have 3 layers. We have the ice edge on the top, that's the shapefile vector layer, and we have the image, and we have the ice chart underneath. Then we remove the images, and that is how it looks, the line or our data that brought it from NextGeo and put it on the ice chart. And I think there is a lot of matching, and we can be confident about that. There is a small things, there is small variation in some places, but I mean that is very common because of the processing procedure. I mean, the ice chart is processed from different satellites. The other things also, there can be variation in time. The ice chart, the ice edge where the line is very dynamic, and it's really important. Maybe Torill and Bente mentioned that. Why we want that? There's 2 ways you can think about it. First of all, from application point of view, navigation, a lot of ships, they are not allowed to come beside the ice because of their category as a ship. They should not be there, because it can be a lot of damage for the ship and for the people on board. The other part also, with this kind of measuring where the ice is, also it's more climate, because each year, like, people thinking about how big is the ice in the Arctic and how that will influence the climate system in the world. The last part, how you make a map from that, then it's also straightforward for QGIS. You just go to the main menu. You will have new print layout. You define your print layout here, and then you click OK. You will get another window or another smaller layout from QGIS, and then or in the layout in the top here there is the add item. You just add item, and then you say add map. Then you take your window and draw a rectangular on the layout. Then the maps, which is you see it on the main QGIS window, it will appear here. So it will appear like that. Then it will be the normal way how to add the most important thing in each map. You need to have a title, you need to have a grid, you need to have a scale, you need to have a grid, you need to have a scale, and you need to have any kind of other information you would like to add to the map. So this is the whole thing that you can add. You can add grid. For example, when you're clicking on add grid, you will get a window. You specify all the information you need about grid, the spacing, the thickness of the line, where they should start, where they should end. North arrow. Also, you have different north arrows samples you can pick from them. Scale par. Also, you can define your scale par if you need it in miles, kilometers, how big it should be. Then the legal order will be imported directly, and any other information. So it will look like that. Now you have a complete or a ready map. It can be used in any document, reports, or publication. Then what you do, you just go export as image. And as we mentioned at the beginning, if you are happy about your map, you create it, you just export it as an image. And there's several formats you can export: PNG, JPEG, and others. You can export it also as PDF files. Then this is what you will get. Now here also I added the line that we draw. I think that is what I would like to know would like you to know today. If you are interested, then we can go back to the question and answer and see. Thanks very much.
I think it's quite easy to get started with, and there's also this nice feature that even if you don't want to or know how to program additions yourself, there is a list of community plugins that you can install in addition to the core functionality that you get when you install QGIS. So there's quite an active also developer community, and they share the plugins through this QGIS.org site. So there's really a lot of help to get, both in terms of documentation, but also in terms of actual pieces of code that you could use for your kind of data. There are QGIS user groups in many of the nations, not only in Europe, but around the world. So there's also a chance that there are other users in your country if you don't find any examples sort of centrally in this QGIS.org site.
According to my point of view, I mean, like, all software available now for image processing or for geographical data, you can define them into two parts, or you can put them in two categories. One of them is raster based, and one of them is vector based. Or what I mean, like, when I say vector based, the vector based is dominated. Like QGIS and ArcGIS, they recently start to introduce image processing packages inside the software. But for MV, I think, personally, I think it is more for raster processing. You will find less functions for geographic or for vector processing in MV. MV is also very good software for image processing, and that is the same like Ardas Imagine and this software. So that is as far as my personal point.